Hello students, this is the next video from acids, bases and salts. Today we will discuss something about salts. Acid and bases we have completed. So now today is the turn for salts. All of you know how the salts are prepared. We have discussed this many a time. Acids plus bases, when they react together, they form salt and water. And this reaction is neutralization reaction. This I have told you in acids also, in bases also. So salts are prepared when acids and bases react together and water is formed in the reaction. Secondly, these salts are ionic compounds. That is, in solution, they gives anions and cations and they can conduct electricity as ions are formed. The next is salts are formed when hydrogen of acids, it is being removed by some cation and this may be metallic or non-metallic. For example, suppose this salt is there, MgSO4. Mg is cation and this is a metallic cation. Mg is a metal. So in this salt, and the acid should be H2SO4. So the H hydrogen ion from the acid, it is being replaced by this metal magnesium here. Or in this case, see, this is also a salt. This is NH4Cl, ammonium chloride. It is made by the combination of HCl, hydrochloric acid, and NH4OH, ammonium hydroxide. Here also hydrogen of HCl is being replaced by this ammonium, which is not a metal. It is a non-metallic cation. That's why I am saying, thus in salts are formed by replacement of hydrogen of acid like H2SO4 or HCl by a metallic cation or a non-metallic cation. Magnesium is metallic cation and ammonium is a non-metallic cation. This is the third property of salts. You know, they are ionic, they have high melting boiling point, they are formed by the combination acid and bases, and hydrogen is replaced. So this is what we call as salts. Now, salts can be classified on the basis of the base and acid which form them into three categories. And these three categories are acidic, basic and neutral salts. So the three types of salts we have are acidic salts, then basic salts and then neutral salts. How these three kinds of salts are formed? Acidic salts which show acidic reaction. What are the properties of these acidic salts? Their pH is less than 7. We know acids have pH from 1 to 7 or 0 to 7. So acidic salts, they have pH less than 7 like the acids. Here H aqueous ions, H positive ions are more than the hydroxyl ions as in acids, and they turn blue litmus red as in acids. So they have these characteristics of acids. That's why they are known as acidic salts. Now the question arises, what is the difference between these three and how they are formed? Acidic salts are formed when a strong acid, like you know the strong acids are three main: hydrochloric acid, sulfuric acid and nitric acid. So this sulfuric acid is a strong acid. When a strong acid reacts with a weak base, this is aluminium hydroxide, AlOH3. So this aluminum hydroxide is a weak base. When a weak base reacts with a strong acid, then acidic salts are formed which have properties of acids. So this is how. So I have written two more. MgSO4, magnesium sulfate, also an acidic salt. Ammonium chloride, also an acidic salt. So you have to write their components, which acid and which base is used to form this, and which acid and which base is used to form this. You write the name of the acid and bases in comment box for me. So this is acidic salts. Now the second is basic salts. As the name indicates, they show some properties of bases. What are the properties of bases? The pH is more than 7. All of you know these bases have the pH from 7 to 14. These bases has pH from 7 to 14. So the basic salts, their pH is also more than 7 towards the basic side. Then H ion concentration, H aqueous is less than OH. Hydroxide is more and H plus is less. They turn red litmus blue as bases do. So these three characteristics are of basic salts which are like the bases. Now again, how these basic salts are formed? They are formed by the combination of strong base and weak acid. All of you know the strong bases are NaOH and KOH, sodium hydroxide and potassium hydroxide, which are also known as alkalis because they are soluble in water. So NaOH is the strongest base, and when this strong base reacts with a weak acid, carbonic acid, though it is a mineral acid, but it is a weak acid. So when they both combine, this sodium carbonate is formed, Na2CO3, which is a basic salt. Likewise, sodium acetate. This is formed by, you have to write in comment box what are the two components of this is sodium acetate. Which acids and bases they are being used to form this sodium acetate. So the next is neutral. So the neutral bases, neutral salts, they are, the example is NaCl, sodium chloride, the normal table salt. It is formed by strong acid and strong base and strong acid. HCl is a strong acid, NaOH is a strong base. When they both combine, neutral salts are formed like NaCl or KCl or K2SO4, and I am writing here KCl also. So you have to write what are the acids and bases used for these neutral salts to form, and their properties are like the neutral, like water or the neutral compound, pH is equal to 7, H is equal to OH, and they have no effect on litmus paper. So in this way we can classify the salts in acidic, basic and neutral salts. Now the next, there is a term known as family of salts. So family of salts, we can have two based on anion and the other based on cation. The name of the anion and cation are used. So here, this is, suppose for example, this is sulfate family. Here the anion is sulfate group, which is an anion SO4 minus 2, and all the salts which are having sulfate group, they are the sulfate family salts like sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, potassium sulfate, ammonium sulfate, any which are having sulfate as anion, they are from sulfate family. You have to learn the formula of all the salts and write their full name also, like sodium sulfate, potassium sulfate. You write the name and learn the formula. So if the anion is same, the family is sulfate. Likewise, with different anions, we can have carbonate family, chloride family, and so on. So with the anion, the name of the anion is used in a family. The second family, if the cation is same, cation may be any. Suppose we have taken sodium as cation for this particular family. So the name of the family is sodium family. So all the salts having sodium as cation will be under sodium family, like sodium chloride, sodium sulfate, sodium carbonate. So all the salts with sodium, they are in sodium family. Likewise, we have magnesium family, we can have potassium family, we can have family with any cation or any anion. This is just a way of classifying different salts in different families. So this is about the general discussion for salt. Now we will do about the preparation, uses, and what next? Preparation, using, and properties of different salts one by one. First of all, I am taking caustic soda. This is the general name of sodium hydroxide. All of you know the formula of sodium hydroxide. NaOH is the formula for sodium hydroxide, and in layman's language, this is known as caustic soda. So first of all, how this caustic soda is prepared? This is the preparation of caustic soda or NaOH. And the name of the process by which this is prepared is known as CHLOR ALKALI process. Why this is special name CHLOR ALKALI process? Because chlor represents to chlorine. Alkali represents to this alkali. NaOH, all of you know, is alkali. So chlor represents chlorine, alkali represents sodium hydroxide, and this is the process CHLOR ALKALI by which this sodium hydroxide is formed or prepared. This sodium hydroxide is prepared by our common salt, sodium chloride, NaCl. So NaCl is used to prepare sodium hydroxide. This is an electrolytic cell in which electrolysis of, I have written here, brine. So what is brine? Brine is the saturated aqueous solution of NaCl. When this salt, the normal table salt, NaCl, is dissolved in very less water and a concentrated solution is formed, it is known as brine. As it is an aqueous solution, so the ions are formed, NaCl, it is dissociated into sodium and chloride ions. And this brine is used for the preparation of NaOH. How? This is the cell, these are two electrodes, anode and cathode. All of you know, cathode is negative electrode and anode is positive electrode. On anode, anions deposit which are negative. On cathode, cations deposit which are positive. So two electrodes are there, and from the upper side, this NaCl solution or brine solution is put in the cell. So brine is coming in. This is a porous diaphragm, and what happens? The reactions takes place. Electricity is passed, and water is there. NaCl is there. All the ions, they are dissociated, and what happens? On this anode, chlorine is liberated. Chlorine gas is formed on this anode, and on this cathode, hydrogen is formed, hydrogen gas, and on the cathode side only, this alkali NaOH is formed, and some NaCl is also coming from unused NaCl also come out with NaOH. In this way, by the electrolysis of brine, this is an electrolytic cell, this is combined with battery and so on. A complete electrical circuit is made, and by the electrolysis of brine, this NaOH is formed, hydrogen is formed, and chlorine is formed. That's why the name is chlor-alkali process. Now, along with this chlorine, hydrogen and NaOH, some other secondary products are also formed by this process. This hydrogen and chlorine, they react together to form hydrochloric acid, which is used in different industries. And also this NaOH also react with chlorine and sodium hypochlorite or bleaching compound. It is also formed as a byproduct of this process. That is, this chlor-alkali process, it forms one chlorine, second hydrogen, and third NaOH. These three products are formed, and two secondary byproducts are formed. One is hydrochloric acid and second is a bleaching agent, sodium hypochlorite. So this is how this electrolysis of brine is done to get NaOH. Now we will write some uses of these different, all the five products which are formed in this process. I am writing, you copy them. I am writing all the uses in brief, very short form. So first write uses of NaOH. First write use of the main product NaOH. We are writing uses first of NaOH. Uses of NaOH. Number one, it is used in soaps, detergents, for making rayon and for making paper. These are different uses of NaOH. Second is, it is used for extraction of silver. All of you know the formula of symbol of silver, from its ores. So this is the second use. Third, it is used in oil refining. NaOH is used in oil refining. And fourth, it is used in cleaning metal surface or degreasing. Grease is being removed, degreasing or cleaning metal surface. So these are the uses of sodium hydroxide which is formed here. You have to learn all the uses of all the products which are formed by this electrolysis of brine. So these are the uses of NaOH. Next, the uses of chlorine. Chlorine gas, the first use is as disinfectant. All of you know, as disinfectant in drinking water. Drinking water and swimming pools. The water of swimming pools, it is being disinfected by chlorine. And the second is in the manufacture of, chlorine is used in the manufacture of bleaching powder, PVC. Write in the comment box full form of PVC. What is PVC? Paints, dyes and CFCs. Write full form of CFC and PVC in comment box. What is CFC? You must be knowing what is CFC and PVC. So this is how, these are the some uses of chlorine. Now the next is the uses of hydrogen. Next we will write the uses of hydrogen. Very important case, all of you know, hydrogen is used as a fuel in airplanes, etc. So uses of hydrogen. First, it is used for hydrogenation. Hydrogenation for making ghee and margarine. Margarine is a type of butter. Margarine. So margarine and ghee for hydrogenation as a catalyst. It is used as a catalyst. Hydrogen is also used as rocket fuel, and in the manufacture of hydrogen is used in the manufacture of hydrochloric acid and ammonia is used, and methanol also. Methanol is methyl alcohol CH3OH. So, and this ammonia is further used for making fertilizers. So these are the uses of hydrogen in hydrogenation as a catalyst, for making ghee and for making margarine, and in rocket fuels, manufacture of hydrochloric acid, ammonia and methanol. Next are the uses of hydrochloric acid. So where this hydrochloric acid is used? Hydrochloric acid is used for making medicines. It is used for making medicines and cosmetics. Second, it is used in leather and textile industry. Textile industries. The third is manufacture of PVC and ammonium chloride. Fourth is cleaning iron sheets. So these are some of the uses of hydrochloric acid in medicines and cosmetics, in leather industry and textile industry, for the manufacture of PVC and ammonium chloride, and for cleaning iron sheets. So these are some of the uses, and the next byproduct is NaClO. NaClO is bleaching compound. It is a bleaching compound or bleach, and its name is sodium hypochlorite, NaClO. The chemical name is sodium hypochlorite. This is the chemical name. You have to learn this chemical name as well as the formula of sodium hypochlorite, and it is a bleach. So it is used for as bleach, for household textiles, etc. Second, for water purification and odor removal. So bad odor, it is removed by putting bleaching powder. You must have seen that in big water tanks bleaching powder is added, and chlorine must be evolved from bleaching powder, which cleans the water and the bad odor is removed. So these are uses of these 5: chlorine, hydrogen, NaOH, bleach, and what next? HCl. So by electrolysis of brine, 3 products are formed and 2 byproducts are formed, and these are the uses of all the 5. So we have learned the preparation of caustic soda or sodium hydroxide and the uses of the products and byproducts of this chlor-alkali process. This is all for today. In the next video, we will learn about some other salts, their preparation, their properties and their uses. This is all. Thank you.